What's happening, people? Hey, hope you're doing great. We are on, can you believe it? No, it's over here. We're on lesson 4-3. Whew. All right, parallel perpendicular lines, guys. Here's all you need to know. Well, maybe not everything, but we're going to learn a couple things. So, parallel lines, guys, we've seen these before, right? Probably not, well, not so far this year, but in previous grades. What is unique about parallel lines? Of course, that's they don't intersect. If you see this symbol right here, just two slash marks, that's the symbol for parallel lines. Perpendicular lines look like an upside down T. Okay, look like that. So there's your two symbols for them. I don't know that we're really going to see them too much, but we need to understand when we write equations for parallel and perpendicular lines, there's something particular we got to pay attention to about their slope. All right, we'll get that once we get in there. Of course, parallel lines never intersect. Perpendicular lines make a 90-degree angle. That's why perpendicular lines are always right. Parallel ones just wrong. Somebody smiled. I saw it. All right, people. Whoa. Okay. Oh no, we're back to having the. Look, now doesn't want to work. We can make this work. Okay, maybe this time it'll work. All right, so just like we've been doing, guys, we are in slope-intercept form, okay? So that hasn't changed. What has changed is what we need to do. So we're going through that point, and then it says we're parallel to this. Okay. Well, if you're not sure what this line looks like, guys, we could graph that, you know what I mean, on Desmos, and that would be great. You know, it's going to graph something, something like this, okay? Well, we want to go through the point 4, -2. So maybe 4, -2 is like right here. And we want to be parallel to that. So I want the same slope, right? I want the exact same slope as this one. Well, can I identify the slope from this equation? I hope so. I hope so, guys. The coefficient of x represents the slope. So that line has a slope of +1/2. So now, this isn't very challenging. Now it just says, okay, what form? Okay, slope-intercept. This one, there we go. I just need to know the y-intercept. Guys, I don't care what you do. If you want to put it in point slope and work your way through into slope-intercept, I think most of us probably like that the best. If you would just like to write y equals mx plus b and find the y-intercept, okay, and do that. I'll do both ways. So I'll go y equals mx plus b on this one, guys. Okay. Replace y, x, and m with what you know. So -2 equals 1/2 times 4 plus b. 1/2 times 4 is 2. All right, this is the number 2. Subtract 2 to move it over here, so -4 is our y-intercept. All right, so write it all together. So the line that will be parallel, guys, to the line that we see here is this one right here. Y equals 1/2 x minus 4. Okay? That's all we're trying to do here today. Okay? Okay. Wow, awesome. I didn't have to go to the back and move this. Okay, so now the same thing, except perpendicular. Okay, so this one's not as easy as parallel lines, guys. Perpendicular, okay? Perpendicular slope. So I say perpendicular slope, okay? And here's what you need to know, guys. It's a very fancy word. Opposite reciprocal. What does that even mean? Opposite reciprocal. Okay, so let's just work through a couple of examples. So if we had a slope of 3/4, okay? Well, what is the opposite of 3/4? Yes, -3/4. And then what is the reciprocal? Put it in the tumble machine, right? So -4/3. These are opposite reciprocals. I know they're opposite because if I were to multiply them together, I get the number -1. Okay? Let's do another one. Let's say we were 2. Let's not do negative 2. Hang on. Let's do negative 4. That sounds much better. Okay, negative 4. Okay, what's the opposite of negative 4? 4. What is the reciprocal of 4, right? So we've got here, again, if you're not sure, guys, just make a fraction, right? Whole numbers are actually a little bit harder, I think. So make a whole number, 4 over 1. Now flip it. So this is 1/4, okay? So that's what we have to do to find our perpendicular slope. Remember, we want 90 degrees, okay? So we're going through 2, 3. There's your point. Here's your slope, right? But we want to be perpendicular to this slope. So if I'm 1/2, right? Okay, opposite is negative 1/2. Reciprocal, negative 2 over 1, which is really just negative 2. That's why I didn't want to do negative 2 over there. We're going to do this one here, okay? All right, so now I know my slope is negative 2. Now we're going through that point right there. I'm going to go ahead, guys, and use point slope, right? All right, so we know we want our m to be negative 2, and then we're going to use that point. So if we're going to use a formula, go ahead and write it out. Then we're going to fill in what we know. And remember, we're going to write, it wants this in slope-intercept form, so we're going to have to go through point-slope form, right, and then into slope-intercept. Again, that literally takes no more work than combining like terms and distributing, okay? So we can distribute, move that 3 over. I mean, we could do this all at one time if you want, right? We know this is going to move over with plus 3. So y is going to be negative 2x. Watch your signs here. Plus 4 plus 3. Okay? Go ahead and simplify this. And we get plus 7. Okay? So y equals negative 2x plus 7. Is there a way to check this? Well, I know the slopes are opposite reciprocal. I would say put it on Desmos, right? And when they go through Desmos, they're going to make a 90 degree, right? Now, they're not going to make that traditional 90 degree that goes up and down, right? Like if we see these two graphed here, 1/2 minus 1 could look like that. Negative 2x plus 7 going to maybe go up there somewhere. You know what I mean? So they're going to kind of be on an angle. So maybe turn your machine that way and look at it. Okay. And guys, really, that's everything we have. You know what I mean? This is just the dumbest question ever. Don't even worry about it. All right, here we go. It says the graph shows the diagonals of the rectangle. There it is. Determine whether JL. All right, so where is JL? That's this one here. Okay, is perpendicular to KM. Now, guys, I'll say it 1,000 times. Pictures, right, are meant to confuse us. Pictures are meant to confuse us in math, okay? So just because I look at those two, I don't know about you, there is 0% chance that, my eyes are pretty good at spying a 90 degree angle. There is a 0% chance, right, that has it. However, sometimes in math, they will draw pictures that mislead you. So while it might not look like a 90 degree angle, it very well may be, okay? Look, if they're going to be perpendicular, I know those two lines will have an opposite reciprocal slope, okay? So all we're going to do is find the slope of those two lines, all right? So look, we're going to go with Km first. Km. Again, just use your ordered pairs. 6, 6, and 2, 1. So 6, 6, 2, 1. Y minus y. Let's see, 6 minus 1. X minus x, 6 minus 2. So this is 5 over 4. Okay. So now we're going to do JL's slope. I'll do that in blue. So here's JL. Again, we're thinking if they're opposite reciprocals, this should be the opposite. Negative 5/4. The reciprocal, negative 4/5. Who's to say? All right, 2, 6, and 6, 1. Not the best looking 6. Okay, let's go ahead and subtract. 6 minus 1, 2 minus 6, 5, negative 4. Oh, we were close, weren't we, guys? So we had negative 5/4. Now, some of you might say, oh, yeah, those are opposites. Those are perpendicular. But they're not. Right? This would have to be -4/5, not -5/4. So determine, no, they're not. Explain it. Well, you could explain it with their two slopes not being opposite reciprocals. Oh, no, we're back to not moving. Okay, hold on. Okay, guys, we got 3 lines. We just have to determine whether or not the graphs of those 3 lines, which are in a couple different forms, okay, are parallel, perpendicular. Okay. Well, I mean, again, pictures are meant to confuse us, but I would spy that the red and green one might be parallel. So let's look at those first, okay? So here's, hold on, we can color code this. All right, so here's the red one, all right? The green one is the 2x. This one, no, that's purple. Okay. There we go. Okay. Let's find the slope of this one real quick. So this is in standard form. So let's go ahead, solve this equation for y, and now I will know what its slope is. So 2x needs to move over here. So this is -2x minus 5. And now I need to divide everybody by -6. Okay. So y equals, this is going to be 1/3. All right. And this will be plus 5/6. See, my computer's going crazy, right? Anyway, okay. So yes, these two are definitely parallel. Okay. So I know this has a slope of 1/3. I need to do the same with this one, right? Again, it looks like it could be perpendicular. And look, if it's perpendicular to the green one, it is definitely perpendicular to the red one because they have the same slope. Okay? So I'm going to get rid of all this. All right, that's in blue. Good news, folks. We can make blue happen. Okay? So here's my blue one. 3x plus y equals 12. Right? 3x plus y equals 12. Again, solve for y. Okay? We're just going to subtract 3x from both sides. And I'm done here. Okay? My slope on this one is -3. M equals -3. So 1/3 and 1/3. So those two lines definitely parallel. Explain, same slope. What's the opposite reciprocal of 1/3? Well, the opposite would be -1/3. The reciprocal would be -3/1, or indeed -3. So yes, these are perpendicular. These are perpendicular. Is it perpendicular to both the red and the green? Absolutely. Okay. Sweet. We're still able. Maybe it's just like an every other slide thing. I don't know. Okay. Whatever. I feel like we just did this one. Determine whether the graphs of y equals, and then here we go. It's giving me a whole bunch of other ones. -2x plus 1, x minus 2y equals 4, and y equals 3 are parallel or perpendicular. Okay, well, let's start with this goofy one here. Y equals 3. What's the slope of that line? Again, it's this line right here. It's just a horizontal line. Remember, our 4 kinds of slope. Positive, negative, 0, undefined. This is one of the special ones. So this has a slope of 0. Okay? So there is no, I mean, like, look, if it was parallel, we'd see another horizontal line. We don't have that. If it was perpendicular to a slope of 0, right, it would have undefined slope. Okay? I don't see any vertical lines here. So nobody is going to be parallel or perpendicular with this one. Let's just look at the slopes of the red and the blue line. Okay? So red line is the x minus 2y right here, okay? So again, we're going to solve this one, put it in slope-intercept form so we can identify the slope. So we're going to subtract x. So negative, I'll just say 1x minus 4, divide by -2. And like really, guys, I don't even care about dividing the y-intercept number here, but, you know, it's just good practice. So 1/2 x plus 2. All right, so slope of 1/2 on the red. Okay, so what slope would we be looking for if, I mean, obviously these aren't parallel. Again, I know I just said pictures are meant to confuse us. We're assuming that it's at least close. So what slope would we be looking for on the blue line, okay, if it was perpendicular? Well, the blue line, guys, right here, negative 2x plus 1. This one has a slope of negative 2. So are 1/2 and negative 2 opposite reciprocals? They sure are, right? So the red and the blue line are indeed perpendicular because they have opposite reciprocals. All right, we're still able to move. Okay. So they've been less helpful here. Now we have to write an equation. Again, we're still in slope-intercept form. That's probably the most common form you'll ever see, guys. Passes through negative 3, negative 2, and is perpendicular to this one. Okay, so step one is figure out what is the slope of this guy right here. And then it's perpendicular, so we got to do the opposite reciprocal. Okay, so this is going to be 4y equals negative 1x plus 12. Divide by 4, divide by 4. Don't really care about you because you're the y-intercept. Okay, there we go. So negative 1/4 is my slope. So if I am perpendicular, right, so we're negative 1/4. So the opposite would be 1/4. The reciprocal would be 4. So now I know I want a slope of 4, okay, and we got to go through that point. I think point slope, guys, probably the easiest thing to do here. So y minus y1 equals m, which is 4x minus x1. Okay, double negatives on both of these. These both need to change really to plus 2, right? Well, to plus, that'll be plus 2. This is going to be plus 3. Okay? Go ahead now. Distribute, combine like terms. That's all I got to do. Okay? So this is going to be y. I know we're going to have a minus 2 over here. It looks like a z. All right. 4x plus 12 minus 2. So 4x plus 10. Okay? There's your line in slope-intercept form that will be perpendicular to the other one. Okay? This doesn't seem so bad. Oh no, we've lost it again, guys. All bad. Good news, I only have one slide left. Oh, we didn't even have a slide left, guys. There you go. Okay. So that should do it here for us. For 4 dash, no. This is 4 dash 3. Wow. Years flying by, guys. Okay. 4 dash 3, all about parallel perpendicular lines. So kind of the same stuff with just a little bit of new stuff mixed in there. So we should be good to go now on our book work, our quizzes, and our homework. But if you have questions, let me know. You guys did a fantastic job today. I will see you guys later.